So this talk is about it's about metadata. It's about metadata that's sort of JSON, and it's about manipulating that metadata with something that's called JQ, and how I use that in some beauty plugins that I wrote to do some helpful things that hopefully I'll show. So I'm going to keep the motivation super short because I think most people know it. And metadata and are important. It's important that they're stored in a structured way. Ideally, they're all stored in the same way, but that's rarely the case. And so manipulating it is useful. And, often, manipulating it in a way to make something non-standard standard might be helpful sometimes. Hopefully, you never have to use this because hopefully the metadata that you encounter are perfect and perfectly standardized. But if that is not the case, which has been my experience, that's fine. In N5, we store metadata in JSON files that are in this kind of tree-like hierarchy where you have a container and then there's folders that contain attributes, data sets of multiple attributes. And ZAR is pretty much the same way, except they kind of split their metadata into 2/3 different kinds of files. Rather, they're both JSON files, but they just store different kinds of metadata. So yeah, these files are all JSON. So processing JSON will be useful for interacting with ZAR and JSON. Let's skip this terminology slide. Thanks. Metadata standards differ, so we might want to write some translation that goes from metadata one standard to another one. Here you see a lot of the stuff that's stored here is the same. There's a scaling transformation. This would be pixel resolution, and it's just stored under a different name in the same kind of structure. So if you have a program that understands this, but you get something with this, how might you write a small program that you just turn one into the other? That's something that we might see today.
Yeah, quick question. So you said ZAR stores two kinds of metadata. Why do they separate these two? Is it storage relevant metadata and metadata, or?
Yeah, it's that. I will go. That's worth saying, but I'll only say that in this case, this stores metadata about the array, and this stores anything that's not about the array, but more user level metadata. What I'm describing here, actually, for future watchers of this on the internet, this is the state of ZAR in version 2. Actually, I just that will change. So in ZAR version 3, it will be something like ZAR.json, and you will have these things separated. At least that is the current proposal, as I understand. In a second, I'm going to show you how you can write custom metadata, but I'm going to skip that here. And I think that's everything I want to say as a preliminary. And now moving to what JQ is. So it's just a command line JSON processor. So think of it like a programming language. It's actually simpler than a programming language. Think of it like a little scripting thing that you can use process. You can program it with it, but it's probably not recommended. So here, there are a bunch of resources that I put here. I'm just going to actually jump to the JQ webpage. So here it is. If you look for JQ JSON, maybe should pop up pretty quickly. But this is the main page. It's worth having a look at the tutorial, which has a bunch of examples. And the manual is a lot of details. Today we're going to be for 1.6. And one other thing I wanted to show you is if you want to follow along or try this in the future without downloading or installing this, let me say downloading and installing this is quite easy since it doesn't depend on anything. But if you wanted to just try online, it's a button. I'll try online here. Yeah, so it brings you to a page like this, and I'll just for a second show you a couple of simple things in this web page. But then we're going to move to the command line since I have stuff set up there. So there's an input and a filter is JQ's name for the program that you run. So this would be the input to the program. So for example, I've got the number there. One simple filter would be not dot plus 2, which says give me the input and add 2 to it, and I get 7 over here that you could expect. So this is like one way that you could try stuff is just put the JSON that you want to play with here. And then you write your little program in here, and then it will give you the answer. So don't worry about exactly what I wrote in the program filter part yet, because the next thing will be a crash course. But if you wanted to play online, this would be a nice place to do it. Cool. So now in like, I don't know, maybe we'll spend 20 minutes or so, we'll do a crash course JQ. Okay. Does this screen look, is it sized okay for Zoom people? Like, can you see stuff all right? I can make this bigger if necessary. I don't hear objections, so I'm going to okay. So the most important, first let me show you, I just have a couple of files here. There's something called like arr.json. And like this is what it looks like. It's just an array that's valid JSON, right? The most important and simplest filter is just dot, which says this is the input. So if I say jq dot r, it gives me the array output, and it default preprints things. So you'll see the file itself had things on one line, but the default preprints things. I also have this object, which looks like this, to show you something all like unprinted, right? I'll just make it a little trashy in here. So I saved that ugly version. If I jq dot the object, it looks right. So this is already a sort of convenient thing. Right? Make ugly JSON look pretty with JQ. Okay. So now we'll actually do some manipulation. First, we'll just do like the very basics, right? We have an array. We already know that dot is the array. The simplest thing you want to do with an array is give me an element. So you use that with brackets and then an index. So jq.0 would give it 0. No surprise, right? And it's 0 index, which is important, but it does what you expect. Yeah. You can also slice. So for example, the colon 0:2 gives you the first 2. So it, think of it as including the first and excluding the second. And as well, if you just give it empty brackets, it gives you everything. So it gives you the whole contents of the array. And like notice that there's no brackets around here, and that like might be important for some cases, but I'm going to ignore this detail for now. Maybe we'll go back to this. This is how you index arrays. Let's look at objects again. So you've got the object thing. Similarly, you just use the brackets to index things, and you might type 1, which is like the index for one of the things like that, and you get what you expect. So the string 1 comes to 1, so we say dot 1, and we get 1. Yeah, and we'll just do 2 to make sure the thing is actually working. I'm not tricking you. If I type things correctly.
That also tells you that.
Yeah, that's also good.
Yeah,
right?
yeah.
No, it's
Invalid.
output. Yeah, and actually, this is a little gross. So there's a shorthand, and you just ignore the brackets and the quotes, so you can just do dot 2, and it also works. And this is nice. Another thing is the question mark is another thing. Like before, I typed 2 and I got null. Maybe you don't want nulls, but you just wanted to put down nothing. And maybe this case. Oh, okay. I'm going to come back to the question mark. The question mark, I think, I want to work the way it's worked, but get back to that. Okay. Question mark. Not a question mark. GW dot question. Dot question mark. I don't think it's right. Okay. We're going to come back to the question mark. Yeah. Maybe it's a bracket. Maybe it's a bracket. Whatever. I'm going to skip it for the moment. And then you saw some things like simple addition, right? If you have things that are cut outputs, you can just add the outputs like this. So I can just 15 because dot 1 gives 1 plus dot 12 gives 12. Yeah, and you get 15. So that's the simplest object stuff. We should also do some assigning. So you can do things like dot 1 equals 1. Then assign the values of these things. And then similar stuff will work for arrays. And then let's see. We should also do like if you wanted to add something to this array, like let's say I wanted to add 3, right? So I should build a new object with 3 and give it 3. So this is probably straightforward. This looks like I'm just building a JSON object, right? Quote 3 of that's 3. So now like think of this as this whole object. And when you add an object to an object, it just like adds the keys in this guy there. So now we have 1, 2, 12, 3. It didn't sort them, or rather, they're ordered now in the order they were added. But there's a way to sort keys if you want to. Cool. Good. So that's everything. That's at least the very basics. Let's do one more thing. Let's say it didn't want 12, so I can del for delete the key 12 in object. And no, it's not. This syntax is like del dot 12. So that's how you remove keys from functions. All right. Now I think we'll do some fancy stuff. Let's go back to the array. And you saw me do this in an example. So there's something called map. And if you, I don't know if you're familiar with programming languages, like I know you will have seen this. Have you seen map in like Python maybe? Or seen map? But good. This is a reason for me to explain it. So first I'm just gonna do this. So the inside of map is like a function or a filter. And what it will do is it will apply this to every element that you see and give you an output that applies it to everything. So this adds one to every element of the array. And you can do even fancier stuff like this, like let's see, if. So now we're going to see actually conditions. It's better to say if something, then something, right? So let's say if it's even. So if the remainder of division is 2, right? So if dot mod 2 is 0, it just means it's even. We'll say then if 1, else negative 1. So now I would expect something that says a new array, and it's the same length. And it should be 1 if this thing is even, and negative otherwise. And that's what we get. 1, negative 1. So you can put very complicated things inside of that. You can even use map on objects. So let me show you what that is. So let's remember what's an object. So we have 1 to 12. Let's do the same simple dot plus 1 on object. And it's sort of what we want, but it gives us an array and not the object as the output, which is kind of weird, right? So if you are doing maps on objects, there's something called map values, which gives you maybe the more expected, usually the more expected thing, right? 1 and 1 plus 1, 2 plus 1, right? So there's a lot of these like convenient, like not even one-liners, but like single commands that do very.
Because in general with JSON, we're expecting to have key value pairs rather than just
right. Yeah, exactly.
But the names suggest exactly the opposite functionality. I would guess that map values maps only the values, maps everything.
Let's talk later. I mean, maybe, but this is the headspace thing.
yeah. I'm assuming there's something equivalent for keys, like map keys. Like if you wanted to +1 them for whatever reason. Like
that's a like rather trickier operation, but it's possible. Yeah. Okay. I'm going to show, so for the future example I have, there's one other like main thing I want to show, which is reduce, which is a way to take like a bunch of things and combine them into one thing. So let's do this in the array. So for example, if you wanted to add everything in the list, multiply everything together, reduce is the way to do it. And it looks like this. So you reduce, and here our input is an array, and reduce wants you to like undo the array. Remember before I showed you that like dot brackets like essentially turn an array into a list of stuff. So you do that. And then it's like a function with two arguments. And the first one is kind of like the thing that you start with. So I'm going to add all of the elements of this list. So I'm going to say the way it's going to work is I'm going to start with 0. And then I take 0 and I add it to this. And then I take 1 and I add it to the result. And then I take 2 and add it to the result, and so on. So this is essentially like the first result or the starting point. Excuse me, I forgot something. In here, we need to give a name to the value of the element in the array for each step that we take, because I told you we have the starting value, but we also in here need to say dot here means the current value, and then we add I. So again, like in here, for the first step, this 0 is this dot, and this I is this 0. And the second step, this dot is the result, which is like still 0, and I is the 1. So like reduce plot as I again. Just the extra clear means each of these values is going to be assigned I once. So I could have finished writing this, but now we expect to have the list. The sum of the elements of the list, which is 10. Let's make sure that's right. 7 plus 2, 5 plus 1, 0. Yeah. And that's how reduce works, but reduce can do like very complicated stuff. We'll see like an example of that. Let me do one slightly more complicated example here, just for fun. Let's start with an empty array, and now we're going to add an array consisting of each element. So now we're going to start with an empty array, and we're going to add to it an array consisting of 0, and an array consisting of 1, and so on. And we get the same thing. That's boring. Let's make it like more complicated. An array containing the array, blah, blah, blah. So now we have an array of 0, an array of 1, an array of 2, an array of 3, an array of 4. That's a simple. Oh, not that simple, but like simple. Give a little bit more, so I'll go slightly further. Okay. You can have functions, and let me put functions somewhere else. So let me move them into here. So I have two examples. One of them is like factorial, and the other one is I think the factorial. Let's start with that. So let me start by saying it's in a file that ends in JQ, and that's convenient since it knows what files that way. Here's what it looks like. You can make comments. DEF and then a name and then a colon is how you say here's a function. And then you just write sort of normal JQ stuff. And here we have reduce, which we've already seen. So now we're familiar with this from before, but now we're multiplying. So we'll start with 1 and then multiply all of the elements together. And here's a new thing where we have range. Let's just see what range is. Range 5. That probably should. So n here just means there's no input, but I could easily, let me first. Dash n just means there's no input or like ignore any input that's there, but because I'm not using the input, I could do this. So this gives me, 4 elements. You can do start at 4 and go to 12. Tricky thing that always messes me up is semicolons, split function arguments. That always messes me up. So I always want to do comments. So and you can also go by 4 plus 2 is 6 plus 2 is 8, and so on. Okay, let's go back to factorial. So now we know what this is, and now we're saying for all numbers starting at 2 and we have to go to the argument plus 1, multiply all the numbers together. And let's just have it there so we can look at it. You can do things like include fact. So this looks for a file of JQ, and because it's there, use it. I'm gonna just ignore this. Something super important. I'm gonna do it here and then explain. Let's say we want to do 5 factorial. I can just type the number 5 and I get the number 5. But if I want to take the number 5 and apply a function to it, use this type thing, like in Bash, for example, and that will make that just says take the output of this and feed it into the input of the next. So if I do the 5 pipe dot, I get 5 again. But if I do 5 pipe fact, then it applies the function fact to its input, which is 5, and you get the thing out. Okay. So we use pipes all. That's all the basics. So you can do quite a bit of stuff now. Yeah, that's like almost everything on my list, and if we have time later, we can do even more stuff. But I guess any questions, or is there any like thing burning that you know that you want to do with your JSON that you want to try something?
Just for a general question, like,
yeah.
what is the use case for this? Like, versus using Python or some other well-established language that has some JSON parsing.
Yeah.
Like, I mean, I think this is great if you know that JSON's all you're going to be working with, but like, does it have functionality beyond that? Like,
yeah, it does not have functionality beyond that. It is for one thing, and it's good at that one thing. It has no dependencies, so installing it is way easier than installing Python, and it's also way more lightweight. So, like, all use case might be you're logged into a server somewhere that doesn't have anything installed on it, and this is like trivial to install. Essentially, that's one use case. Also, I'd expect the programs that do pretty complicated things are very short. We did pretty complicated things in like a line or less than a line, and that's also quite nice. I can show you. I can show examples later because we're going to do like kind of complicated examples now. So let me show you a simple example actually, because that's maybe better. And the more complicated stuff we're going to see. This is why I have stuff over here. I can't find that example. But let me show you here. Like this is an example where the author grabs like commit messages from their Git repo and like filters those based on the committer date, for example. And so like formats this like ugly JSON with a lot of crap to just say this committer did this message, for example, and the whole thing is this. Let's see. Yeah. Let me show you what this is. This is the JSON that they're processing, and with this short message, they can get it to this. That's pretty nice. Okay. Yeah. So let's move on to some other things. We did the demo. First, I'm going to show you how we use it in ImageJ. And first I'll show you how to export like an N5 container with custom metadata. And it uses this. And the way that it uses this is like ImageJ images have a lot of metadata attached to them. And what the N5 exporter does is take that metadata and formatted it to JSON like this. And then you write a JSON or JQ program that is understood to have all of this stuff. And then reformats it in the way that you want. And then it will dump that to that N5 container. And it'll be easier to see with an example. So let's do that. I've got the classic boats image. So let me make sure you're writing it into here. Too. So we have this empty folder, and we're going to be writing stuff to here. This is in Fiji file saved as export N5 into this, and you write where you want to write things to here. So, like usually, if you write something, let me first write it like no metadata. If we just write this, there's something called boat. Boat attributes has this is the bare bones N5 stuff, so nothing custom. Now let's do this again. If we wanted to do the custom stuff, just going to be like hotkey this from now on. So if you wanted to use JQ program stuff, you choose this custom option here. And then when you press OK, another dialog pops up in which you write your JQ program. And this should like kind of familiar. You know, we're just making an object. Let's say we want our resolution to be in the resolution D. And we know we want to stick X resolution, Y resolution, Z resolution. And we know that those are there because if we go to this page, we see this list of variables that are there. Okay. So now if we press OK, hopefully I wrote something. It did. Let's look at both attributes. And yay, we see resolution. Let's do. Yeah, I just have a hotkey set up here that runs JQ and dumps the result of this back into this. Yeah, see. Yeah. Yes. It's one of my favorite things. Agreed. Agreed. Cool. Let's do something more fun. So this is, you know, there's a lot of stuff here, but it's pretty bare bones. Put a bunch of stuff into this other metadata property. Essentially, image pluses have a place to put essentially arbitrary metadata. So for this, I have a little script that I'll run to just put some data in there. So let's see. So I'm just going to stick a name into that properties, and I'll put like an organizer, so it's like an array there. So I ran this, and now this image has this new information there. And now let's re-export custom. Now we have name, and there is a name. There's this name. So let's put that name under name. But there's also, let's say if there's a real name. Real name, and now I stuck that in the other metadata dot name. And what else? We had, what we can say, we had other data dot organizers. I think how I had it, right? Organizers, yeah. Anything else you want to put here? I'm actually not testing work. I don't want to like test it. Let's see that. Now we can say, okay. My plugin is protecting me from erasing data. I have to delete this. so careful in my programming. We'll just skip to stuff. Name.
Probably could if it's not close with dialogue. It's fit to
Yeah, I mean, the thing is, you can't make that decision until I try. It's like a close to the dialogue first.
Yeah, but it can reopen the dialogue.
Yeah, that's a lot of work. You want to do it with me? So yeah, now our sub's serial name, which is both real is that name that we had an extra metadata resolution is still there. Interestingly, this is kind of weird because notice it's like a string. It's a string that kind of looks like an array. This is just like a technical detail. If you wanted to, you could write JQ that turns this string into JQ and then unwraps it, but exercise. That's the homework. So that's how you can use it to write custom metadata, for example, using the M5 plugin. Okay. Now we're going to do something more complicated. And for that, our next task will be, we have this data set, which is always our data set.
Can I ask a quick question?
Yeah, please, good.
So, if you use the tips that already has some metadata,
Yeah.
would it be able to pick up
Yeah, as long as bioformats puts the metadata in the image to image, this should have access to it. If it doesn't, let me know first, and then it's either my fault for not having the right field there for JQ to see, or it's maybe bioformat's fault for not putting it in a place where JQ can see it. But yeah. Possibly, that's probably a bioformats question and not a me question. Yeah.
yeah, so this would not be used as a way to convert some sort of metadata that's expressed without into
Not easily, correct. But if that's, yeah, that's a maybe involved question. We could talk because that might not be that hard, but we'll see. Cool. Yeah, so in the next section, we're gonna give 20 minutes, which I think is enough time to do. We're gonna do some more like digging, and we'll do some like complicated function writing. And the goal will be to make this one. Let's first open this data set with M5 viewer, which you can go to plugins, data viewer. Let me just shove this folder in here. You can see something, and it's trying to be smart. And it will let you open this. So I'm going to just open this, and we do see an image, which is good. But the metadata are wrong, and I'll show you what I mean. So if you look at the top right here, these numbers, they're like in the order of a few hundred, whatever units, spatial units those are. And that's just raw pixels, units of raw pixels. Z array. So we're going to look at the Z array, and so this array is size 600, 400, 480. So that's what these sizes are approximately, and we want them in, say, nanometer units. So our problem is M5 viewer can open the image, but it doesn't see the right spatial metadata. So we're going to write something to turn this image into something that M5 viewer knows, and it'll take a couple steps. And it's a bit complicated, so first we have to like step back and like remember how stuff is stored. And then we'll have a bit more complicated just data moving around. So let me first tell you what the goal is. First, let me show you what's in here. In this folder, there's that C adders that we saw before, and this is what holds everything. So here's how we know, for example, that it's in nanometer units, because we see nanometer here. And then we have the multi-scale images, and there's 3 of them, and one of them is going to be 64 nanometers isotropic resolution, and the next one is going to be 120, and the next one's going to be 26. But all of that stuff is stored up here. And if you look at like in S0, there's Z patterns here, but there's nothing really useful there. So N5 viewer wants the information at S0, not at that terminal. So our task is going to be to take some information from the top and move it like inside each scale level, essentially. And an annoying thing is that there's like a lot of different JSON files in here. Remember, if we go over here, our setup looks something like this, right? We have this, and then these 2, and then these 2. And we want to move stuff from here to here, basically. And that means we have to like process different JSON files at the same time, because we have to move stuff from one to the other. And there's ways of doing it in JQ, but for the purposes of the Fiji plugin, we have like a standardized way of like merging all of these. And the way to do it, the way we do it, is we make this big old tree. Let me show you what it looks like. So if our tree looks like this, we make a JSON file that has everything in the tree and the structure of the tree. So here we have something called children, and it has something called group 1. And it has children. Its children are level 0 and level 1. And all of the attributes that are in the attributes.json or the Z array or the Z adders, all that stuff goes in the attributes here. So our task is we're going to have a big JSON file that looks like this, which actually contains all of the information in all of the JSON files. And we're going to essentially be moving stuff from like in here to like here. Is that sort of clear as a start? I'm going to show you specifically where we're going to start. Go ahead.
It's because an N5 viewer needs that orange JSON file for an N5.
Yeah, or let me say that slightly differently. It needs the JSON information that's located like, up here to be needed here. So there's like annoying technical stuff that I don't want to talk about, but I might if it's not clear after we go through this.
Are you able just to map it? Like if you want to move something from one place and using map function, or
Yeah, it's not as simple as I'd like. So ideally, I'm showing it in like it will be more complicated than I'd like probably. Part of why I'm doing it in the way I'm doing it is like to show functions that we haven't seen yet. That's you. But it is not too hard to move things around. It is not too hard to move things around. And if there's time at the end, I can show you an even like faster way of doing it. Yeah. Actual question, or should I just continue? Just continue. Okay. Oh, I see
Maybe
the
it's just-
blurry. Yeah, that's weird. So this is what our tree is going to look like. So remember that the attributes of the root held everything in for that star, right? So this is all of the stuff that we saw. And all of the children had not much. This is everything that's in S0, and it's only the array stuff. What we're going to want is something that looks like this, where now, for example, this is S2, and the attributes in S2 contain all of the array stuff, which is from here up. But we'll also move the axis information in here. We'll move the coordinate information, transformations information in here, and we'll add something called pixel resolution, which for this demo is what N5 viewer wants. grab this. Okay. I'll just show you to start what it's going to look like. So I have calling it MGFF solution. And we're going to make a function that I think I called convert, hopefully. And if we just run it on in, we'll mess up because I messed up
So maybe the quotations is
Or
convert.
is double quote after convert.
Yeah, thank you. Yeah, good. Thank you. I can never see. So good. Whatever I did, it put pixel resolution in here somewhere. So that's a good sign. So we're just going to fill in a couple of things. And I did a bunch of things. Most of these are really simple and like a little bit overkill, if I'm honest. Like if you knew exactly the structure of the tree, you could skip a lot of the stuff I'm writing here. But part of why I'm writing it this way is to show you what walk does. But we're going to fill in 3 functions. This one, I don't even think we do need this one. And then 2 and 5. So we'll just go through these step by step. And then I have something called walkthrough. So we're just going to look at what each one does. So first we're going to do just see what these things do. And then fill in what we have to. We'll understand what we have and what we want for the functions that we need to write, and then we'll do it. Okay, but we had get children, and this is saying dot children is give me the value of the children key. And remember, that's going to look like kind of this. And it's going to give me the keys of that, which in this case are going to be group 1, 2. So this is basically saying, give me the names of the folders below. So let's make sure that that does expect. Cool. So S0, S1, S2. That's a good start. It has multi-scales. This says for dot attributes, does it have a key called multi-scales? So again, this is essentially looking in here and saying, is there are multi-scales out there? So it should say, this should give us true because at the top level, we can have multi-scales, but if we look into the children, or we look into like children.s0, it should be false. So I'm expecting true false. Cool, true false. So now we just have functions that say like, do we have the information that we need at the level that we're at? Now what's next? Now we have to make this function. And so this is a complicated function that just like adds a bunch of objects together. But let me show you what the input and output of the things that we want are, and then we'll see like what the motivation is there. So so this is the thing that I want to make of that function. So this is going to look a lot like the children object. So notice that we have like something in S0, S1, S2, and these are going to be corresponding to the things below us. And these are objects that just have some data in them. And specifically, I stuck the coordinate transforms in there. And I do this because if I take this and I just add it to my children, it will add all of this stuff to children in a fairly straightforward way. This is more complicated. Or explaining this is more complicated than I expected, but let me show you what the key part of the addition is. This is just grabbing the multi-scales. This is calling the function that we're gonna make and just storing it as a value. I didn't show you how variables work, but if you write as $, blah blah blah, that's how you make a variable. And this is going to say for all of my children, do something. And it's going to add the stuff that you made to all of my children. You can look at this elsewhere if you want. This looks grosser than it is because this is, again, taking an object and adding two objects to it. And I just have to index by the children, which is a little bit complicated. If you knew I only had C1, C2, S1, S2, S3 or something, you could make it simpler. But if you want to ask the JSON, what are your children, what names of your children, arbitrary stuff, like a little process. Okay. But I'm gonna remind myself so that we don't waste too much time here. But I'm gonna also move this to. I want to look at just look at our input while we do this so that we understand what we're doing. So we're gonna, our inputs to this function is gonna be, it's gonna be this multi-scales object. And remember, I want to make something that has S0 and S1 and an S2 object. So I need all of that information is inside of data sets. So I'm going to just work with data sets. So first, let me just get data sets. And this is going to look weird for a second. No, it's not going to look weird for a second. Data sets is an array, so I'm going to reduce on the array. So now I want to make an object, and each object needs to have a certain key. So let's start with an empty object. So we're going to start with an empty object, and now we want to add something to it. So let's add something to that empty object. Dot add. Now I want to add a new object because you add objects to objects. What's the key of this object? It should be dot path. So I have to get the path of I. And annoyingly, I have to. So now I'm just saying, make me an object that has a key S0. And then later it'll make me an object with a key S1 and a key S2. And what do I want the value of that to be? I want it to be, well, I can do whatever I want, but I'm just going to have it be I. So now I will have something that says S, and it will be this object. And then I will have an object with S0, and its value will be this. Another object whose key is S1, and its value will be this, and so on. And that's what it'll dump out. Let's make sure that worked. I forgot what I called this. Oh no, I did it in the walkthrough, didn't I? I did. Yes, good. So actually, I have the cheating for this. So remember, the input to this thing that we wrote was the multi-scales object. So this is grabbing the multi-scales object, passing it to the thing that we did. Let's see if we succeed. Nice. S0 and its value is that stuff, right? S1, its value is that stuff. And pretty much what we did is, again, we just grabbed this value, made this the key, shoved everything in there. And that was, the reduce was a little, it's a little bit of text, but the meat of it was I.path goes to I. Okay, we got 5 minutes. So this is like the partitionation part. So the last thing that we want is we want to turn that coordinate transform stuff. Let me show you. So the function I wrote is also going to shove the axes into something. And we already did the work of getting this stuff, the coordinate transports in there. I want to turn the result, the thing on the left, into this on the right. So I'm gonna make you all write these actually. So actually, let's make sure we can see everything, and then you're gonna tell me what to write. So this is here. So how do I start to make the thing on the bottom right? I'll only do one thing. I will say we want to make an object. So I opened an object. Now tell me what's next.
This object has key pixel resolution.
I like that. Key pixel resolution.
That's an object.
So you want me to open it?
Yes, this object has key dimensions.
Good.
This dimensions has a value of the other thing.
It's an array, so I'll just do the array for now.
Yep.
And now we have we'll fill the array in. And then
The units.
yeah, let's do unit first. So where can I get unit here? So let's say I want to get it from just three options. Let's say I want to get it from this one. So how do I get this?
Dot access.
Axis. And now I have an object here, and I want. It's
You have an array.
It's an array. Yeah,
So
that's
it's
So-
access bracket 0 dot.
Okay, I dig it. Now let's do dimensions. So now I can actually just grab directly this. So now, yeah, what do? And then, yeah. Actually, I don't need the array. Yeah. All right, cool. And actually, yeah, we're done. So that's it. So this function is done. This I'm going to skip because we don't have time. I'll show you what it is. You know, I didn't need it, but it's just, does it have a certain type? Does the type have an attribute? Does that other stuff have certain attributes? So, cool. We're done. I'll just show you what the result is. So I'm just going to copy all this stuff. I can, no. Ignore this. So we're going to do the same thing as before. We're going to open N5 viewer. Now let's back again. Set it there. Let me show you one thing first. If you can put just like the dot in here, and if you press detect data sets, it'll show you some results in here. And basically you see the input and the output trees here. So you see like children S0 and S1 is here. Just so that you can like debug stuff you want in here. Sometimes you get weird results, and I don't know, it's just strange. I found it helpful. So now we're gonna stick our results here. We're just gonna write convert, which is the function that we sent to convert. Moment of truth. I pressed the result, it did something. Let's make sure that there's stuff in here. Good, I see this here. Do I see? I want to make sure that there's the resolution somewhere. Yes, there. So that's a good sign already. Let's try to open. And it does. Now we see instead of like maybe a couple hundreds or thousands, okay. We succeeded. I'm over time. I do want to show one last thing, which is only that there are Python bindings to this. So we do IGQ checking one in one, and I'll show you. We have like some data. You can have like give me 2 plus 2, right? This is just our normal JQ filter, and it applies it on the data. You can do IGQ. I don't know what we want to have here. I figured that one. Okay. Thank you. Your mileage of Python may be very questionable.
I think the point is outside the.
That works.
Add semicolon.
Oh yeah.
Yeah, output.
Yeah. There.
Never noticed.
I also never noticed these things. Good, good, good. That's everything I wanted to cover at that time. So let's just summarize. I find JQ useful for stuff. You might also, you can write custom metadata with the Fiji plugins the way I showed you, and if you have like some container with metadata that you can control. So obviously you can write the metadata yourself, make the metadata have what you want, but if it's something in the cloud that someone else has control over, and you have a tool that can't edit it, but needs to be formatted a certain way, this might help too. So that actually, that is not cool. I guess any other questions? I can show some other stuff, or we can just stop. Also, thanks to people. But
Hey, John, I was wondering a little bit about how efficient this is. So when I've done something similar with, say, XPath and XQuery for XML documents, what I find there is it tends to kind of reiterate over the search space. And so I'm wondering, is this using some kind of indexing or hashing to make that sort of thing more efficient?
I guess it depends on the details of your question. Are you asking about searching for particular things, or if you like all the examples I've shown so far, so you know where in the document you're looking for? Are you saying, suppose I want to look for something, like filter stuff based on values or something? Is that what you're more asking about?
Something like that. So let's say I have a very large JSON file, right? And so I have two options, right? I could make something that's going to iterate over each element of the JSON file. And then as the elements stream in, then I process them and build up my structure. Alternatively, I could populate my structure by using a bunch of JQ, I don't know what you want to call them, queries. Right, but then that might actually end up visiting each element more than once, and possibly even result in reparsing the file. So I'm wondering, when you use it in that application, if your objective was to actually parse the entire file, would you want to use JQ for that, or would you use some other method?
I probably would use this. You can write inefficient code with JQ, but it provides you mechanisms to be efficient too. So, for example, the streams versus the arrays is where this comes into play. If you have a stream, it touches every element of the stream independently, so it's not holding on to everything at one time. It's also written in C if that matters. I mean, it's low level and it's fast. And I haven't been doing, I don't have huge problems that I've asked it to tackle, but I know people in the world, like on Stack Overflow, have questions like these, and they seem to have not run into limitations.
Yeah, it's really a question about scaling because, for a small JSON file, it doesn't matter either way, really. But I've encountered situations where I've written it works fine for some small file, but then I get something huge, and suddenly this is taking, it's scaling with the square of the number of entries or something like that, and so that's where things get a little bit concerning.
Yeah, I expect there are ways to use JQ in a way that can scale very nicely.
Okay.
If again, there's also ways to write JQ filters that scale poorly. Yeah.
Okay, cool.